For millennia, humanity has developed a fascination with the night sky, so much so that we have discovered how it evolves over billions of years. So in this video, we will explore the life cycle of stars from their creation to their supernovae. Let's start in one of the most beautiful places in the universe, the Nebula, which is the birthplace for stars. It is an enormous clump of dust and gas clumped by the gravitational force. As more matter gets attracted, this clump grows bigger, which in turn makes the gravitational force stronger as it scales with how massive an object is. And the clump spins faster too, causing it to heat up. After around 1 million years, the massive dust cloud collapses in on itself, forming a protostar. Now, at the protostar stage, a hot dense core forms at the center. There is still a massive dust cloud around the star, so over hundreds of thousands of years, all of the matter around gets sucked in, causing it to grow and spin even faster. Before becoming a star, the protostar moves onto the T-Tauri stage, where its core still isn't hot enough to start a fusion reaction, but is shining brighter than a regular star. The star will stay here for around 100 million years to feed on the matter around it. After the core exceeds 10 million kelvins, the star enters the main sequence. This is the stage that our Sun is in, where the star undergoes nuclear fusion, which produces a tremendous amount of heat energy. This force fights against the gravitational force that tries to collapse the star, creating an equilibrium. 90% of the star's life cycle is spent here, depending on how big the star is. For stars like our Sun, it will burn for around 10 billion years. For smaller stars, they will burn for up to 50 billion years, and for massive stars, they will only burn for around a few hundred million years. For the smaller stars like our Sun, when they run out of fusion fuel, their outer layer expands into a red giant, while cooling down after billions of years, releasing all of their matter as nebulae. And once the star reaches 100,000 kelvins, it becomes a white dwarf, which continues to lose energy for hundreds of billions of years until it becomes a dead black dwarf. Now the more exciting part. When the massive stars, 8 times more massive than our Sun, burn through fusion fuel, they expand into red supergiants, reaching monstrous sizes. But when their fuel runs out, their gravitational force collapses into the star. Because they are so massive, this collapse causes so much force that the star implodes into a supernova. This implosion flings the remains of the star everywhere, forming countless nebulae for future stars. After the supernova, the massive star leaves behind either a neutron star, a star made of neutrons as a gravitational force fuses the protons and electrons together, or a black hole that swallows matter around it if the star is massive enough. And there we have it. From a clump of dust in a nebula, gravity squishes them into a protostar. As they gather up more material, their core becomes hotter and enters the main sequence when it's hot enough for nuclear fusion. If the star is smaller, it will expand into a red giant and collapse into a white dwarf, but if the star is massive, it will expand into a red supergiant and implode in a supernova, leaving behind a neutron star or a black hole. I hope that you all have learned something interesting today. Thank you for watching, and stay hydrated.